Addition of vectors. In this module, you'll learn about addition of vectors with the triangle method and the parallelogram method. If a car moves 12 meters east and then 4 meters east, it covers a total distance of 16 meters due east. Its final position, or the effective vector, or the resultant of the two vectors, is a simple addition of two displacement vectors. Again, if you travel 10 meters east and 5 meters northwest, then your displacement vectors are not linear and your resultant cannot be by simple addition. For addition of such vectors, which incline to one another, you need to apply the triangle method or the parallelogram method of vector addition. The triangle method is applied if two vectors can be represented in magnitude and direction using two sides of a triangle taken in the same order. In this case, their resultant can be represented in magnitude and direction by the third side of the triangle in opposite direction. Let us now understand the triangle method for addition of two vectors OP and RS. To add the vectors, place the vectors in such a way that the terminal point of the vector OP coincides with the initial point of vector RS. Now, the resultant vector is the vector from O to S. Note that the resultant vector makes an angle alpha with vector O. For determining the magnitude of the resultant vector, extend OP to ON and draw an altitude from S to meet ON at N. Let angle SPN is equal to theta. In the triangle PNS, using the trigonometric functions, the value of SN is equal to PS sine theta and PN is equal to PS cos theta. Now consider the triangle ONS. The magnitude of the resultant is calculated by taking square root of the sum of squares of ON and NS, which are OP plus PS cos theta and PS sin theta, respectively. Further, by using the trigonometric identity sin squared theta plus cos squared theta is equal to 1, and then simplifying the above result, you get the magnitude of the resultant vector as square root of OP squared plus PS squared plus 2 OP PS cos theta. Let us now find out the direction of alpha of the resultant vector. For this, first take the tangent of alpha for the triangle OSM, which is PS sin theta upon OP plus PS cos theta. Now, on taking the tangent inverse of this value, you can determine the direction alpha. Now that you have learned about the triangle method, let us explore the parallelogram method. You need to apply this method for addition of the vectors, which are acting simultaneously at a point. If the vectors can be represented in magnitude as well as direction by the adjacent sides of a parallelogram, their resultant can be completely represented in magnitude and direction by the diagonal of the parallelogram through that point. Consider the vectors OP and OQ, starting from the common point O. Let the angle between these vectors be theta. To understand the parallelogram method for addition of these vectors, complete the parallelogram OQSP by drawing lines parallel to the vectors OQ and OP. Now the resultant vector can be represented with the vector OS, which is one of the diagonals of the parallelogram OQSP. Notice in triangle OPS, PS is parallel and equal to the vector OQ, and the sum of vectors OP and PS is vector OS. Moreover, vector OS, the diagonal of the parallelogram OQSP, is also the resultant vector of vectors OP and OQ. Thus we can say the triangle method and parallelogram method are equivalent. Since the two methods are equivalent, the magnitude of the resultant vector OS of vectors OP and OQ will be the square root of OP square plus PS square plus 2 OP PS cos theta, and its direction will be tan inverse of PS sin theta upon OP plus PS cos theta. Now that you've learned about the methods for adding two vectors, it may be interesting to learn that these methods can be used to add more than two vectors. You can do this by taking any of the two vectors and adding them to each other, and then adding the resultant vector to the next vector. In this module you have learned the resultant vector is the vector that can give the effect of the vectors which are added. The resultant vector of two linear vectors is a vector with its magnitude as a sum of the magnitude of the vectors and in the direction of the vectors. Resultant vector of two vectors inclined to one another is determined by the triangle method and the parallelogram method of vector addition. In triangle method, two vectors are given both in magnitude as well as direction by two sides of a triangle in the same order, and their resultant vector is given by the third side in the opposite direction. In parallelogram method, two vectors simultaneously acting at a point are given both in magnitude and direction by the two adjacent sides of a parallelogram, and their resultant vector is given completely both in magnitude and direction by the diagonal of the parallelogram from that point. The magnitude of the resultant vector is square root of OP square plus PS square plus 2 within brackets OP PS cos theta. The direction alpha of the resultant vector is the tangent inverse of PS sin theta upon within brackets OP plus PS cos theta.